You hear the burner kick on under the tank, you get a few minutes of warmth, and then it goes quiet again. Or you head down to the basement for the third morning in a row to press that little red button, and by the afternoon it has popped right back out. Either way, the heater keeps shutting itself off, and you are stuck restarting a machine that refuses to stay running. Here is the thing to understand first. Your water heater is not failing at random. It is switching itself off on purpose because a safety device inside it is doing exactly the job it was built to do. So the move today is not to keep forcing that switch back on. It is to find what the switch keeps reacting to and clear that. I have spent years around these tanks and read through the manufacturer troubleshooting guides, so I will keep this in plain language while you stand in front of yours with a flashlight. Before you touch anything, you need one piece of information because it splits this whole problem cleanly in two. Is your heater gas or electric? Look at the bottom of the tank. If you see a gas line running in, a burner cover down near the floor, and a metal vent pipe heading up out of the top, it is gas. If instead you see a thick electrical cable going into the top or the side and there is no vent pipe at all, it is electric. Gas and electric heaters shut off for completely different reasons. Find your type, then follow that section because the two barely overlap. While you are down there, check that the temperature dial is not cranked near the top. Set it to about 120 degrees. That is plenty hot for real showers, safe from scald burns, and a setting that runs too high makes every shut-off problem here more likely. One quick safety note first. If you ever catch that rotten egg smell of gas, do not light a thing, do not flip any switch, get everyone out and call the gas company from outside. Let me take the gas heaters first. On a gas unit, keeps turning off almost always means the flame lights and then dies. How long it burns before it quits is your biggest clue. A flame that dies in seconds points one way, a flame that runs a few minutes and then drops out points another, both trace back to the same safety circuit. A thin metal sensor sits in the pilot flame, and the heat makes it generate a small signal that tells the gas valve it is safe to keep the gas flowing. Lose that signal and the valve shuts the gas down. So the whole gas diagnosis is one question: why does that signal keep cutting out? Start with a no-cost fix because plenty of people are stuck right here. When you relight the pilot, you have to keep the control knob held down for a solid 30 to 60 seconds after the flame catches. That sensor needs the time to warm up enough to hold the valve open on its own. Release the knob after a few seconds and the valve reads it as no flame and cuts out. If it dies the instant you let go, try again and count slowly to 60 before releasing. If it dies after a couple of minutes instead, that timing usually means the flame is slowly starving for air, and there are two cheap reasons. The first is the one almost everyone overlooks. Nearly every gas heater built in the last 20 years draws its combustion air through a screen at the very base of the tank. That screen behaves like a lint trap, and in a dusty garage or laundry room, it packs full of lint, hair, and grit. As the burner runs, it burns air faster than the clogged screen can feed it, so it quits a few minutes in. That is the textbook keeps turning off pattern, and clearing it costs nothing. Vacuum that screen and the grate around the base until the mesh is open and slide anything stored against the tank away so it can breathe. The second air problem is a clogged pilot opening. A tiny orifice feeds the pilot and it gums up with dust, rust, and even spider webs, leaving you a small lazy flame that cannot keep the sensor hot. With the gas shut off, clear it with a thin wire and a shot of compressed air. While you are looking, judge the flame. A healthy one is strong, steady, and blue, and it should wrap the very tip of that metal sensor. Yellow, weak, or floppy means it is starving. If the flame looks strong and blue and the heater still will not stay on, the sensor itself is the suspect. Check it in 3 steps. The nut where it threads into the gas valve can loosen or corrode, so tighten and clean that connection first. The tip can drift out of the flame over the years, so bend its bracket gently until the fire wraps it again. And if neither helps, the part is simply worn out, which is the most common real failure on a gas unit. A replacement runs about $15 to $20, and most people swap it in under an hour. If you own a multimeter, set it to read direct current millivolts, heat the tip in the flame, and look for somewhere around 20 to 30 millivolts. Much under 20 and the part is done. A few other things kill a gas flame. A strong draft will do it, an open garage door, a furnace vent close by, or air pushing back down the flue. If your heater only quits when it is windy or a door is open, you have found it. And while you are at the flue, make sure exhaust is actually rising up and out, because a flue that backdrafts is a carbon monoxide risk and worth a professional look. Here is one almost nobody knows about. Most modern heaters carry a flammable vapor sensor, and it will lock the whole unit down when it detects fumes nearby. Gasoline, paint, paint thinner, fresh paint, strong cleaners, even a stored gas can will set it off. Once it locks out, the pilot will not light at all, and a small status light usually blinks a code to tell you why. If your heater quit right after you painted the garage or parked something smelly beside it, move the source, air the space out, and reset the heater the way your manual spells out. Then keep that stuff away from an open flame for good. Only after all of that, with a strong flame, a sensor that tests fine, and nothing fuming nearby, do you look at the gas control valve? That is the box on the front with the temperature dial, and inside it sits a magnetic coil that holds the gas open. When that coil weakens, it drops the flame no matter how perfect everything else is. A new valve runs about $150 to $550 installed because it has to be matched to your exact heater. On a tank already past 10 years old, that money is better put toward a replacement. Now to the electric heaters, which shut off for reasons that have nothing to do with any of that. On an electric unit, keeps turning off shows up one of two ways. Either the red reset button on the thermostat keeps popping out, or the big double breaker at your panel keeps tripping. Both are safety cutoffs, and both are telling you something is genuinely wrong, so please hear this part clearly. Do not just keep pressing that button or flipping the breaker back. The red button is a high limit switch, and it trips when the water reaches about 180 degrees. If it keeps popping, the water in your tank is actually overheating, and resetting it again and again is how people end up scalded. So the real question is, what keeps overheating the water? The most common answer is a stuck thermostat. It is supposed to shut the heating element off once the water is hot, but when it sticks closed, the element just keeps cooking the water until the high limit trips to stop it. The next answer is a heating element that has shorted out or grounded against the tank. A failed element keeps drawing power and making heat even after the thermostat tries to cut it off, which either overheats the water or trips the breaker outright. Both you can check with a cheap multimeter, power killed at the breaker first, and both are cheap parts. A thermostat is $10 to $20, an element is $10 to $50, and a plumber will charge a couple hundred to fit either one. 3 more things round out the electric side. A thick layer of sediment on the bottom of the tank insulates the lower element and the sensor near it, creating a hot spot that trips the reset, so flushing the tank can clear it. A loose or scorched wire connection throws off its own heat that the high limit reads, or it trips the breaker, and if you open the panel to a burning smell or a melted blackened terminal, stop right there and call a pro, because that is a 240 volt fault and a fire risk. And once in a while, the high limit switch itself simply wears out and trips with no real overheating behind it, which a pro confirms by ruling the others out. That last point sets the line for the electric side, and it is worth saying straight, if the breaker trips again after a single reset, or the red button pops back within minutes of you pushing it, you are done diagnosing, and it is time to bring someone in. A fault that keeps tripping is live, and it is not something to keep poking at. So here is what comes next, depending on your machine. On a gas unit, if you have held the knob a full minute, cleaned the pilot and vacuumed that air screen, confirmed a strong blue flame, and tested or swapped the $15 sensor and it still drops out, the gas valve is your remaining suspect and likely your cue to weigh a new heater on an older tank. On an electric unit, the day that reset button refuses to stay in after a single push is the day you stop and call, before the overheating turns into a real hazard. Keep an eye on how long the heater runs before it quits, because that timing keeps pointing you at the right part. A heater that switches itself off is not broken the way it feels. It is flagging a fault and waiting for you to clear it, and the moment you do, it holds. I have dropped links to a universal thermocouple kit, a multimeter, replacement heating elements, and a can of compressed air down in the description, so you can grab whatever your step calls for and get the hot water back today.